Hello friends, and welcome to another lecture on chemical engineering thermodynamics. Today we shall discuss about chemical potential. This is Professor Arvind Prasad. For a mixture of I components, we know that the total Gibbs free energy is going to be a function of temperature, pressure, and the number of individual species in it. The change in Gibbs free energy is going to be equal to the change in Gibbs free energy with respect to temperature plus the change in Gibbs free energy with respect to pressure, change in Gibbs free energy with respect to the change in number of moles of a particular species holding the other species constant. Now the change in Gibbs free energy is going to be minus S dt plus V dP plus summation of over all the I components mu I dni, where mu I is equal to dou G by dou Ni holding pressure, temperature and all the other mole species constant. Mu I is nothing but the chemical potential. In thermodynamics, chemical potential of a species is energy that can be absorbed or released due to a change of particle number of the given species. As we can see here, in this U-tube manometer, the liquid falls in the right leg and rises in the left leg. Now, why does this happen? Because the potential energy tries to equalize itself on both sides of the tube. It's also observed that when the potential energy on both sides are equal, the flow of the fluid stops. Well, the potential energy on any side of the leg of the U-tube manometer is nothing but rho into G into H. Now, at equilibrium, dg is equal to 0. Therefore, summation over I mu I dni is equal to 0. From this, we get a conclusion that for multiple phases in equilibrium, where the multiple phases are alpha, beta, 2 pi, mu I alpha is equal to mu I beta, so on so forth is equal to mu I pi. Now, if you have an isolated system which is under equilibrium, a vapor liquid equilibrium, where the pressure and temperature of the vapor phase and the liquid phase are constant, we can deduce that mu I, where mu I is the chemical potential of any species I in the liquid phase, that is mu IL, will be equal to mu I vapor, that is chemical potential of any species I in the vapor phase. As you can see, like in the U-tube manometer example, for phases to be in equilibrium, the chemical potentials should be equal. And the chemical potentials, if the phases are not in equilibrium, change in such a way so that the phases come in equilibrium when the phases are in contact. Now, we need to understand one thing, that the change in chemical potential is due to change of mass, that is mass transfer from one phase to another phase. This is a very important point to note. That's the end of my lecture. Please like and subscribe my channel and do write comments on what you have understood and what you have not understood. I shall take your comments and reply them. Goodbye.